A piece of aluminum block is in place for the limits for the XY popping box. The four side surface is machined flattened, and it is used for calibrations of X and Y positions of both front and rear spindle. The front spindle position was calibrated previously. Is now to calibrate the rear spindle by touching the tools on it. You can touch it mechanical, or you can touch it in electronic. Its circuit is connected to it by low voltage electricity, or use a spinning pop. The rear portion was machined and now is machining the front portion, and the shaded area was marked on the rear. That when the cutter goes to here during front portion processing, it always don't cut the piece of the tool surface made by the front and rear spindle. Across the middle area. And it is around 0.03 to 0.04 millimeter. And the front and rear end is only 0.01 millimeter. And the middle portions, there's the overlapped area, is just 0.03. Now we go to the next turn, the milling of the rear portions by the rear spindle. The same milling cutter is mounted on the rear spindle, and before we need to poke the Z2 length on the tester, so that its two position, height position, getting the same value as the front spindle one. After the cuttings, the rear and the front portions made with of wood. You can try the feelings and also use the dial gauge indicator to test it. I tested it only have differences of depth around 0.01 or 0.015 millimeter. Moving of a small rectangular pocket and hole on the rear end. machining of this long workpiece finished. It's done by the twin spindle. The matching line is on the center line of the workpiece, and I can feel it. The matching is quite good. Although it may take a longer time to machine this long piece with the two spindles, but the method is possible, and a certain amount of time needs to be spent on the setting up, and precision setting up will give a precision results. And remove the headstock and see the rear portion. And it must be taken care in machining by twin spindle. Collisions of the workpiece during machining must not be allowed. And if it happens, the precisions will be drastically reduced, because when one of the spindle hit on workpiece, the relative displacement or position of two spindle will appear, because you know this kind of router machines are not strong enough in the strength of the structures, and after the collisions, one of the spindle will display relatively with the others a little bit. So during the continuous machining on the rest of machining process, the location will be affected, and the dimension will not accurate. And this podcast is done by this rear EZ line and spindle. I can feel the bottom is very smooth. It's only done one step in a rough pocket. And in my previous experiences, that was machined by this EZ line, the bottoms may have some burrs, and here I can feel there is none of burr, very smooth, and it's due to the using this THK EZ lines. You can refer to my previous video and see the construction of this EZ line. It is very rigid in compare with the original EZ line. And now this long piece finished except some pockets on this side surface. I will do it by turning into 19 degrees later on. Thanks for the watching.